Hello, and welcome again to FlippedHarber for Precalculus. In this video, we're going to cover section 1.6, Lines. Our objectives for this lesson are to find and interpret the slope of a line joining 2 points, graphing a line given a point and a slope, find the slope-intercept form in an equation given in general form, show that 2 lines are parallel, find a line parallel to a given line, show 2 lines are perpendicular, and find a line perpendicular to a given line. Our topics include calculating and interpreting the slope of a line, graphing lines, find the equation of vertical lines, use the point-slope form of a line as well as identifying horizontal lines, writing the equation of a line from 2 points, find the equation of a line in slope-intercept form, identify the slope and the intercept of a line from its equation, write the equation of a line in general form, and finding the equations of both parallel and perpendicular lines. Let's start with the slope of a line. You should already know this, but I want to go over it again. We know that the slope is equal to the change in the y values over the change in the x values for 2 points on this line. Now we need to make sure that we don't have 2 points that have the same x value, because we can't divide by 0. If the 2 x values are actually the same, then the line is vertical and the slope is said to be undefined. When we're graphing a line given a point and a slope, we start by plotting the known point. Then we apply the slope as rise over run. So we move up or down and left or right the appropriate number of spaces. If the slope is positive, we make sure that we move up and right or down and to the left. If the slope is negative, we apply that negative to only the rise or the run. So we move down and right or up and left. The equation for a vertical line is just given by x equals a, where a is some real number. A is also referred to as the x-intercept, that is where the line crosses the x-axis. One form of a line that we can use when determining a line is what we refer to as the point-slope form. It's useful when we know one point, x1, y1, and the slope of a line. Again, you should be familiar with this. A horizontal line is going to be y equals b, where b is a real number, and it's also the y-intercept of the line, where the line passes through the y-axis. When we want to find the equation of a line given 2 points, we actually start by using those 2 points to find the slope. We just apply our slope formula with the 2 points. Once we have that slope, we use the new slope in one of the 2 given points in the point-slope form. Now we quite often start in the point-slope form, but we rarely ever stop with the equation in the point-slope form. What we usually leave the line equation in is the slope-intercept form. Again, you should be familiar with this. This is just a refresher. The slope-intercept form is y equals mx plus b. M is the slope and b is the y-intercept. Here's the general form of a line. It's not real useful when we're graphing or anything like that, but the general form can be useful in some applications. A, B, and C are all real numbers. We can't have A and B both being 0. One of them can be 0, but not both. In order for 2 lines to be parallel, their slopes have to be equal. If 2 lines have equal slopes, then they're parallel. In order for lines to be perpendicular, that is, cross at a right angle, then their slopes have to be negative reciprocals, or when we multiply their slopes we get a -1. Let's take a look at how to graph the line passing through the point 1, 3 with a slope that's equal to -2/3. Now again, we start by plotting our point 1, 3, that is over 1 and up 3 from the origin. Now from this point we're going to apply our slope. Now our slope is negative, and you need to remember to only apply that negative to either the rise or the run. Don't go down and left. Go down and right, or up and left. If we apply that slope in both directions, we have 3 points now, which is usually enough to plot a line. But if the lines are too close or you think you need some more, you can go ahead and just apply the slope again. Once you have enough points plotted that you think you can draw that straight line successfully, go ahead and draw the straight line through the points. Let's graph the line passing through the point 0, 3 with an undefined slope. Well, we can go ahead and plot the point 0, 3, that is, it's on the y-axis at 3. But what's an undefined slope? Well, an undefined slope means that our line needs to be vertical. So we'll actually just draw a vertical line through the point 0, 3, like so. Basically, it's the y-axis. Let's find the equation for the line with the x-intercept 4 and the y-intercept 4. Now the thing to remember here is we're actually giving you 2 points. The x-intercept is the point 4, 0. The y-intercept is also a point, the point 0, 4. So really this is all just a problem where they're giving you 2 points and they want you to find a line. So let's go ahead and start by finding the slope of our line. Take our change in y over our change in x. We find out that our slope is -1. Now we'll take that slope and one of our points and put it into an equation. Now if you really stop and think about this, one of these points is really super convenient to use, and it's actually the y-intercept. They're telling us that our b value is 4. So I can go ahead and just put in a b value of 4 into the slope-intercept form. So I get y equals -x plus 4. Now this is the way that you should really give your equations for lines unless they specify something different. If they ask for the equation of a line, you should always give it in slope-intercept form. If they say give the equation of a line in general form or something else, then you can go ahead and use that form. Let's find the equation of the line parallel to the line x minus 2y plus 5 equals 0. So that line's in general form, and it's passing through the point 0, 4. Again, they're telling us our b value. So the first thing we need to do is actually take the equation given in general form and put it into slope-intercept form. We move the 2y over because it's negative, and then we divide by 2. So we've got y equals 1/2 x plus 5/2. What we're actually interested here is the slope. We know that the slope is equal to 1/2, and we want to create a line parallel to this. So our line also needs to have a slope of 1/2, and it needs to have a y-intercept, a b value of 4. So again, pretty easy to give the equation. Let's find the slope and y-intercept of this line. So it's given to us kind of in general form. General form should really have the x value first, but it's definitely not in slope-intercept form. And we really want it to be. So we'll go ahead and move the 3x over to the other side, divide by the 2, and we've got y equals 3/2 x. So this line is now in slope-intercept form, but what the heck's our intercept? Well, since we don't see a number added or subtracted at the end, that means that our y-intercept is 0. So our slope for this line, m, is equal to 3/2, and our y-intercept, typically the letter b, is equal to 0. So a lot of this should have been reviewed. You should be very familiar with working with lines, both their slope and their intercepts, working with them in slope-intercept form, point-slope form, and even the general form. This homework does include graphing, so don't forget about those special graphing rules. Alright, we're all set, so I'll see you in class and I'll see you online.